Namaskar. Very warm welcome to all the viewers in this very special series of CIET NCERT. I am Renu Bhatt with you all, and you are watching us live on PM eVidya channels, channel number 6 to 12. And apart from these channels, you are with us on our YouTube channels as well, that is NCERT Official and NCERT PM eVidya class number 6 to 12. And dear learner, this is our very special series. It's a 5 days, 5-hour series on empowering teachers with artificial intelligence. आज उसका दूसरा दिन है और हमने बहुत कुछ जाना कल इसके पहले दिन, लेकिन आज हम किस विषय पे बात करने वाले हैं वो भी हम आपके साथ शेयर करते हैं। आज हम बहुत इंपॉर्टेंट टॉपिक पे बात करने वाले हैं। द टॉपिक इज आर्टिफिशियल इंटेलिजेंस एंड मशीन लर्निंग, एंड लेट मी टेल यू वेरी इंपॉर्टेंट पीस ऑफ इंफॉर्मेशन। दिस सीरीज इज ऑर्गेनाइज्ड बाय AI सेल CIET NCERT। हम चाहते हैं कि आप बहुत ज़्यादा से ज़्यादा संख्या में इस इम्पॉर्टेंट सीरीज़ का हिस्सा बने और आप इससे जुड़े। दिस सीरीज़ इज़ फॉर एजुकेटर्स ओनली। आप अपनी नॉलेज को इन्हांस कर सकते हैं किस तरह से आर्टिफिशियल इंटेलिजेंस आपकी टीचिंग लर्निंग प्रोसेस को इफ़ेक्ट करता है, इम्पैक्ट करता है और आप उससे बेनिफिट लेते हैं और अपनी टीचिंग लर्निंग प्रोसेस को और ज़्यादा सरल बनाते हैं। आपको इस पूरे हफ्ते बताया जाएगा। और जैसा हमने आपको बताया कि हमारा जो टॉपिक है, आज हम बात करेंगे आर्टिफिशियल इंटेलिजेंस, AI एंड मशीन लर्निंग। इस टॉपिक पे हमारे एक्सपर्ट हमारे साथ जुड़ चुके हैं। सो विदाउट एनी फर्दर डिले लेट्स क्विकली मीट हिम। यू आर डॉक्टर अमित भगत, यू आर एसोसिएट प्रोफेसर, डिपार्टमेंट ऑफ मैथ्स, बायो एंड कंप्यूटर एप्लीकेशन फ्रॉम मौलाना आज़ाद नेशनल इंस्टीट्यूट ऑफ टेक्नोलॉजी भोपाल। वेरी वार्म वेलकम सर, स्वागत है आपका।
थैंक यू।
यहाँ पर हम अपने सभी थैंक यू सो वेरी मच सर फॉर योर प्रेशियस टाइम। यहाँ पर हम अपने सभी देखने वालों से ये कहना चाहेंगे, स्पेशली ऑल दोज एजुकेटर्स जो हमारे साथ जुड़े हैं, आप अपनी क्वेरीज, अपने फीडबैक्स, आप अपनी बातें हमसे शेयर कर सकते हैं। हमसे जुड़ने के कई तरीके हैं। हम चाहते हैं कि आप इन सभी का इस्तेमाल करें और हमसे जुड़े, हमारे इस लाइव इंटरेक्शन का हिस्सा बने। आप हमें कॉल कर सकते हैं हमारे टेलीफोन नंबर पर जो है 8800 440 559। Either you can drop a mail as well with all your feedbacks and queries if there is any. हमारा ईमेल एड्रेस है aicellciet@gmail.com. It's aicellciet@gmail.com. इसके अलावा अगर आप हमारे YouTube चैनल्स पे हैं तो लाइव चैट बॉक्स में जाकर अपना कमेंट ड्रॉप कर सकते हैं। आप जैसे ही कमेंट ड्रॉप करेंगे आपकी बात तुरंत हम तक पहुंच जाएगी और आप जो भी बात हमारे एक्सपर्ट के साथ शेयर करना चाहते हैं, उनसे पूछना चाहते हैं, वो बात उन तक पहुंच जाएगी। आर्टिफिशियल इंटेलिजेंस आज हमारे जीवन का एक अभिन्न अंग है और काफ़ी हद तक काफ़ी जगहों पे इसका इस्तेमाल किया जाता है, लेकिन किस तरह से एजुकेटर्स के लिए बेनिफिशियल हो सकता है या है, आपको इस पूरे हफ्ते बताया जा रहा है। यहाँ पे एक बहुत ज़रूरी इन्फॉर्मेशन आपके साथ हम शेयर करना चाहेंगे सभी एजुकेटर्स के साथ, जितने भी लोग हमसे जुड़े हुए हैं। हम आपको बता दें कि आपको रजिस्ट्रेशन करवाना होगा इस पूरी सीरीज़ के लिए। ये 5 दिन की सीरीज़ है और आपको दीक्षा पोर्टल पर जाके आप जा सकते हैं। वहाँ पे आप अगर आप सर्टिफिकेट लेना चाहते हैं, प्राप्त करना चाहते हैं, तो उसके लिए आपको एक क्विज़ अटेम्प्ट करना होगा। 5 दिनों के लिए रजिस्ट्रेशन प्रोसेस ऑन है। आप अपना रजिस्ट्रेशन ज़रूर कराएं CIET NCERT की वेबसाइट पर जा करके। और अगर आप सर्टिफिकेट चाहते हैं तो आपको ये पूरा कोर्स अटेम्प्ट करना होगा, एक क्विज़ अटेम्प्ट करनी होगी दीक्षा पोर्टल पर एट द एंड ऑफ दिस सीरीज़। और वहाँ पर जाकर जब आप 70% और उससे अबव को स्कोर करेंगे, देन आफ्टर ओनली तब आपको सर्टिफिकेट प्रोवाइड किया जाएगा। सो वी वांट यू टू पार्टिसिपेट इन ह्यूज नंबर्स। कोई भी क्वेरी हो एक बार ज़रूर हमारे साथ आप शेयर करें। और यहाँ पर हम अपने इस सेशन को, इस टॉपिक को स्टार्ट करना चाहेंगे। यहाँ पर अमित सर हम आपके पास आएंगे और हम आपसे जानना चाहेंगे, ऑल्दो वी आर इन टेक्नोलॉजिकल एज राइट नाउ, हम इस समय पर ना तो हम टेक्निक से हम अवॉइड कर सकते हैं, ना ही हम इतनी सारी चीज़ें जो हमारे आसपास चेंज हो रही है हम इसे अवॉइड नहीं कर सकते, क्योंकि ये हमारे कहीं ना कहीं हमारे सपोर्ट के लिए और हमारे इन्हांसमेंट के लिए है। तो जब हम बात करते हैं आर्टिफिशियल इंटेलिजेंस एंड मशीन लर्निंग की, तो इसको आप प्लीज़ एक्सप्लेन करें। बट एट द वेरी बिगिनिंग ऑफ दिस सेशन वी वांट यू टू एक्सप्लेन अस अबाउट द कंटेंट दैट वी आर गोइंग टू हैव फॉर दिस सेशन सर। Amit sir, over to you.
Thank you so much, ma'am. Thank you for the introduction, and I welcome you all in this series of AI series for the teachers. And today we'll be going through artificial intelligence and machine learning. So the contents which we'll be covering today are artificial intelligence and its applications. We'll see artificial intelligence versus machine learning, and then we'll try to find out the different types of machine learning, that is supervised, unsupervised, semi-supervised, and reinforcement learning. Then topic related to all of us, that is how to use AI ML in education, and then AI ML applications in education, that is personalization, grading, and prediction. And last but not the least, most important, the ethical risk when we use AI and ML. Okay, so I'll be start. So shall I start with my presentation?
Sure, sir. Please continue.
Yeah. So as we all know that artificial intelligence is a buzzword. Everyone is talking about artificial intelligence, but before going into its definition, let us try to understand what intelligence means. So here, intelligence refers to the ability to perform tasks that typically require cognitive abilities such as learning from experience, understanding language, recognizing patterns, and making decisions and solving problems. And as human beings, we are doing it quite naturally since our birth. So actually, we keep on learning from experiences. We understand different languages. We recognize patterns. We make decisions, and thus we are being able to solve different problems. And it's quite natural for us. It's like a cakewalk for us. We do it on daily basis. But when we try to give this intelligence to a machine, then comes the term artificial intelligence. So, an artificial intelligence refers to the development of computer system capable of performing tasks that typically requires human intelligence, such as reasoning, learning, decision making, and perception. AI encompasses a wide range of technologies, including machine learning, deep learning, and NLP. So what we are trying to do here with the help of artificial intelligence, that we want a machine to have all those cognitive abilities which we are having as human beings. That is the ability to reason, learn, and make decisions. So you want a machine to have a brain where it will be able to apply reasoning. It will keep on learning from its own experiences. It will make decisions, and thus the machine will be able to solve a problem. And up to a very large extent, we have been able to do it in different segments of our day-to-day life. So today, there is no aspect of our life which is not being affected or where AI is not there directly or indirectly involved within our own lives. So these are few applications of AI in real life, like in healthcare, agriculture, retailing, productivity in work, and personal life. We are using artificial intelligence. So with respect to healthcare, I would like to mention here that AI is transforming diagnosis, treatment, and the patient care. How? Like in medical imaging, AI models like Google's DeepMind analyze X-rays, CT scans, and MRIs to detect diseases like cancer and fractures with very high accuracy. And in predictive diagnostics, IBM Watson helps predict disease progression and suggest the personalized treatment. Now, the personalized treatment is possible because for the same disease, different people have different symptoms and they require different kind of treatment. Further, in healthcare, with the help of AI, we can also do drug discovery. So AI speeds up the finding new drugs. That is, in case of COVID-19, the vaccine was researched. Again, coming down to the agriculture. So in agriculture, crop monitoring, like drones and AI models identify the pest attack, disease, or the water stress in crops. It also being applied in yield prediction, where machine learning predicts the crop output using weather, soil, and the sensor data. In retailing, we all know that we all go to different social media website, we go to different e-commerce website and keep on purchasing different articles. So there we get the personalized recommendations. So Amazon and Netflix uses AI to suggest the product or the content. Chatbots and virtual assistant. Now AI powered chatbots help with queries and orders, like in Flipkart and H&M, where the moment you visit this website, you keep on getting the different suggestions, which actually make you or compel you to do more to make more purchasing. And then it also helps in inventory management. Okay. Further, with respect to productivity at workplace, so there is automation in all the industries. So automation of the routine tasks, like tools like PRA, which is UniPath and Blueprint, it handle the repetitive office work. In with respect to other segments, like in predictive maintenance, in manufacturing, AI predicts the machine's failure before they actually happen. So before this, the scenario was like that when a machine totally broke up, then we start repairing work. But now with the help of AI, it can actually predict the machine failure in advance so that the production line does not get affected. And in case of personal life, we all are using different voice assistants at our home, like Alexa, Siri, and Google Assistant, which helps us to manage our day-to-day tasks and to help us in smart home control. Further, we also have smart home devices like AI controls the lighting, temperature, and the application based on the user habits. And it also helps us in social media feeds and navigation and mobility. So there is no aspect of our day-to-day life which is not getting affected or where AI intervention is not there. But how does AI does all these? So actually, artificial intelligence is a bigger umbrella where we want a program which simulate the human thinking process by the machine. That is the bigger perspective of the AI, where we want a machine to start thinking like human, to have the cognitive intelligence as human beings have. And under this, like the application part comes with the help of machine learning. So machine learning uses data and algorithms to imitate human learning, improving its accuracy by building on the collected insights. So machine learning is actually the application part of the artificial intelligence. And when we go deep down to it, like when we want actually to have a cognitive knowledge, when we want to imitate human brain, and human brain is actually made up of billions and millions and billions of cells, and all these cells are actually neurons. So when we want to actually mimic this neuron into a computer system, then we go towards deep learning. So deep learning actually helps us to process the data, huge amount of data, very effectively. Now, with respect to the comparison of artificial intelligence versus machine learning, so in broader sense, we can say that artificial intelligence is human intelligence exhibited by the machine, which we want to do. But machine learning is an approach to achieve this AI. And machine learning is a subset of artificial intelligence, where artificial intelligence is the outermost layer. With respect to the programming, in artificial intelligence, we require a full programming to make the system, whereas in machine learning, it does not require any hard-code algorithm because the algorithm is self-learning. It keeps on learning by itself. We'll see it further. And in case of artificial intelligence, it is more complex as one has to know everything because it involves multiple aspects of a human intelligence. Whereas with respect to machine learning, it is less complex than the AI. So formally, what machine learning is? So Arthur Samuel actually coined this term of machine learning, and he said that it is a field of study that gives computers the capability to learn without being explicitly programmed. So what does it mean? That on right hand side, you can see that in the traditional programming. So what happens in traditional programming? That we feed the input program logic and run the program to get the output. So what happens towards this right hand side, if you can see this diagram. So in traditional programming, we give data and program to a computer and it generates some output. Say for example, I have written a program to generate a payslip. So the moment I give some data and input to the program, every time it produces the same output. But what happens when we write a machine learning program? In machine learning, we feed the input, output, and run it on a machine during training, and the machine creates its own logic, which is being evaluated while testing. So in machine learning program, we give input to the model. Along with input, we also have the output. So input and output is being given as an input to the model. Model learns the pattern which is available there, and it actually generates a program as an output, not directly an output, but it generates a program or a set of rules. So this program or set of rules will actually learn the pattern of the given input data, and when the new data item comes, it predicts because it has already learned. So thus, this is the basic difference between the traditional programming and machine learning, that in machine learning will be given data as an input along with the output, and it will produce some rules as the output. Okay. Now the formal definition of machine learning was given by Tom Michel, where he said that a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task T as measured by P improves with the experience E. Quite a confusing definition, but in simple terms, we can understand it like machine learning is a technique that enables computers to learn from data and improve their performance on a specific task. It involves teaching machines to identify patterns and relationships in data that they can use to make decisions or predictions. The process of machine learning involves three key elements, that is specific task, the learning algorithm, and the data. So in any machine learning program, first we need to have data, huge amount of data. We have a task to accomplish, and then we have this model which keeps on improving its performance. The more data it will be having, the more it will be able to improve its performance. Okay. Now these are some terminologies which we generally use in machine learning. So I thought to share it with all of you that you must understand these basic terminologies. First is a model. So a model is a specific representation learned from data by applying some machine learning algorithm. A model is also called a hypothesis. So whenever I say that I have applied a classification model or a clustering model, so a model is nothing but a set of rules which are being used to solve a particular type of problem. Okay. And thus we say that a model is there. So all the machine learning algorithms are basically being known as different models. Then when we talk about the data, a data comprises of different features. So a feature is an individual measurable property of our data. A set of numeric features can be conveniently described by a feature vector. Feature vectors are fed as input to the model. For example, in order to predict a fruit, there may be features like color, smell, and taste. So color, smell, and taste are the input features which can help us to predict a particular fruit. That would be our target. The next point, the target of the label. A target variable or a label is the value to be predicted by our model. For the fruit example discussed in the feature section, the label with each set of input would be the name of the fruit like apple, orange, or the banana. So based on the color, smell, and taste, we can actually predict that which particular fruit is this. Okay. And in order to do this, suppose we have ample amount of data with respect to the fruits, then we will actually divide our data in two parts. First is the training part and second is the testing part. So in training, the idea is to give a set of input or the features and its expected output labels. So after training, we will have a model or the hypothesis that will then map new data to one of the categories trained on. So try to understand the scenario that suppose I have 100 records of fruit. So what I'll do, and all these records means we have different features like color, smell, and taste. And along with that, we also have the output feature that based on color, smell, and taste, which particular fruit is this. I'll give this data as an input to a machine learning model, but I'll not give these all 100 records to the machine, to the model. What I'll do, I'll give 80 records as the training record so that the machine learning model will learn over this data. And based on the features of color, smell, and taste, it will try to figure out that which particular fruit is this. And then lastly, we have the testing or the prediction data. So once our model is ready, once the model has learned, it can be fed a set of inputs to which it will provide a predicted output or the label. And that predicted output is the name of the fruit. Thus, with the help of all these basic terminologies, like we need to have a model, we need to have data, which will be having features, that we have to have the target value, the output value, and then the training and the testing data. Now, the machine learning can be broadly divided into these subsections. So the types of machine learning are supervised machine learning, unsupervised learning, semi-supervised machine learning, and reinforcement learning. So the very first point where we talk about supervised learning, so it says that supervised learning is when a model is getting trained on a labeled data set. Labeled dataset is one which have both input and output parameters. In this type of learning, both training and validation datasets are labeled as shown in the figure below. So you can see in these two figures that the very first one, left-hand side, we have user ID, gender, age, salary, and last one is purchase. So based on the input features, that is user ID, gender, age, and salary, we are trying to find out whether a particular user has purchased an article or it has not, or he or she has not purchased. So if the 0 is there, it means no purchase. 1 means yes, he has purchased some article. Similarly, on right hand side, again, it is a supervised model, the supervised learning, because the data set is labeled. There is a label associated with all the features. So on right hand side, it is temperature, pressure, relative humidity, wind direction, and based on all these input features, we will try to find out the wind speed. Okay, so supervised learning is a learning where the data is already labeled, where the features already have some name. Okay, this supervised learning can further be divided into two categories, that is classification and regression. So classification is a supervised learning task where output is having a definite labels, that is discrete value. So in this previous diagram, you can see on the left hand side where I have written classification, that the output value is a discrete value in 0 and 1. So we can actually find it out that the output, whenever the output is discrete like 0, 1, yes, no, or either it is pass or fail. So whenever I can actually classify the output in 1 or 2 or 0 or 1, then we'll be using the classification algorithm. Like for example, Gmail classifies mails in more than one classes like social, promotion, updates, and offers. So every time our classification needed not be the binary one, it can also be a multi-class classification. So we can classify data in 0 1 also, and we can have multiple classifications. So the moment an email comes, the algorithm which is running there in Gmail, it categorizes the email with respect to its content and send it to a particular folder. You would have seen on your Gmail account on left hand side, we have social, promotion, and updates, and it keeps that particular, sends that particular email to the desired destination. On the other hand, in case of regression, it is a supervised learning task where output is having a continuous value or the numeric value. So in this last figure, you would have seen that on right hand side, when we are talking about this data where we have temperature, pressure, relative humidity, and wind direction as the input, the output is not discrete, but it is a value. It is a continuous value within a certain range. So when the desired output is a numeric value, we actually apply regression. So the two types of supervised learning is classification and regression. And the example of supervised learning algorithms are linear regression, k-nearest neighbor, Gaussian naive Bayes, decision trees, support vector machines, and the random forest. So we'll go through it one by one. So far we have seen that in order to apply a machine learning model, we must have data. We must have, so we will categorize that data within training or testing. We'll have a model. We'll give it to a model which will learn the pattern and it will produce some output. Now, how to do it in supervised learning algorithm? First is linear regression. So what happens in linear regression? That it assumes that there is a linear relationship between the input and output, meaning the output changes at a constant rate as the input changes. Now, this relationship is represented by a straight line. For example, we want to predict a student's exam score based on how many hours they studied. So we observe that as a student study more hours, their score go up. In the example of predicting exam score based on the hours studied, the basic features would be, so we'll have two variables here. One is independent variable and one is dependent variable. Independent variable is, so obviously, if I have to figure it out, how many hours a student is studying, if he's studying more number of hours, he'll be able to score more marks. If he's studying less number of hours, he'll be scoring less marks in the exam. So the independent variable is hours studied because it is the factor we can control or we can observe. And based on number of hours a student has studied depends his score. So the exam score, because exam score becomes the dependent variable on this independent variable because it depends on how many hours a student has studied. Now you can have a look at this particular diagram. So here you can see that suppose all these green dots are basically different students, and x-axis is the number of hours a student has studied and y-axis is it shows his score. Then we can see that the data is a sort of linear, but it is not 100% linear. If it would have been 100% linear, तो हमें एक सिर्फ सिंगल ग्रीन लाइन की ग्रीन डॉट्स की एक सिंगल लाइन दिखती जिसपे वो एक स्ट्रेट लाइन होती, बट इट इज नॉट, इट इज स्कैटर्ड. But again, it is actually growing linearly from left to right. It is growing linearly. So we can see here that the more number of hours student has studied, like if we are moving from 0 to right hand side on x-axis, then we can see that the moment I start moving from 0 to x-axis on right hand side, then the moment I increase number of hours, then definitely my score also increases. So what is the task of linear regression is to find the best fitting line by minimizing the prediction errors. So actually, right now this particular line is at this position. So I could have drawn this line here also. I could have drawn this line here also. But our task in linear regression is actually to draw a line in between the given data points. The condition is that the line should be as near as possible with respect to all the data points. And because it is a line, so it calculates the coefficients for the variables that minimizes the error in prediction. So this line cannot go over all the data points. So the data points which are on this particular line, so the prediction would be correct, right? On the other hand, the points which are far from the given line, then definitely there would be some error. What does it mean? That now look at this particular example. Suppose again we have all these data points in red dots. Our task is to put a line in between. So suppose this is the line which we have drawn, and we all know that the equation of line is y equals to mx plus c. So here we are trying to find out these two coefficients of theta1 and theta2, because the value of x and y is already known to us. So I know a particular value of x, and with respect to this value of x, I'm trying to find out the value of y. Okay, so our task is to put a line in between, but how best this particular line is, it depends upon this particular formula. Okay. Now what happens that suppose I have drawn this line, and as per this line, all the data should come over this blue line. Now a new data point comes, which is actually this yi, which is a bigger red dot. But my prediction says that ideally it should have been at this place, this black dot. So definitely there is an error. There is an error between this is the predicted value where I had predicted that the point should come over this point over the line, but actually the point has came at this place. So when I'm trying to find out that if someone has studied this many number of hours, then how much score would be there the student will achieve. So in order to find it out, definitely there is a difference between the predicted value and the actual value. So we call it a random error. So this is the rare error between the predicted value and the actual value. And it actually signifies that what is the difference between these two. And our task is to minimize this error in linear regression. So ultimately our task in linear regression, because data is being given, the data which is given is in a linear fashion. So we try to put a line in between and minimize the error in linear regression. Second algorithm under this is k nearest neighbor. It is quite a simple algorithm where again you can see that our data is being divided into two categories. One is class A and second is class B. So k nearest neighbor is a supervised machine learning algorithm generally used for classification, but it can also be used for regression tasks. So we have seen that there are two categories of data. One is classification, one is regression, where the output is in binary form or the output is in the form of a number. It works by finding the k closest data points or the neighbors to a given input and makes a predictions based on the majority of class for classification or the average value for regression. So in this, our task is that I have a class of stars here, I have a class of triangle here, and when the new data point comes, this question marks, so I need to actually decide that it belongs to this star one or to the triangle one. How to do it? What we does that we calculate the equivalent distance of this particular point with respect to all other data points. And when I calculate this distance after I have this equivalent distance with respect to all other data points, we have certain value of k. Suppose k equals to 3. So I have actually checked its distance with all the near data points. And then with respect to the value of k, we make a circle or a cluster of the elements which are nearest to this new data point. So with respect to the distance of this particular data point with the nearest available other data points which were already there, and we have calculated their distance because the value of k is 3. So I can actually check its distance with 3 nearest data points only. If the value of k would have been 5, हम 5 अलग अलग डेटा पॉइंट से इसका डिस्टेंस कैलकुलेट करते हैं. राइट नाउ बिकॉज इट इज 3, so I've checked that these two triangles are near to this and one star is near to this. Again we'll actually do the voting. We'll calculate which is having the higher weightage, and higher weightage goes with the triangle or the class B. Then definitely we'll assign this particular new data to class B. Thus it is k nearest neighbor, so we actually keep on checking the nearest neighbor of a particular new data point and we assign it to that particular class. Third type of machine learning model is naive Bayes classifier. So naive Bayes is a machine learning classifier algorithm that predicts the category of a data point using probability. It assumes that all features are independent of each other. Naive Bayes performs well in many real-world applications such as spam filtering, document categorization, and even in sentiment analysis. And why do we call it naive Bayes? Because its name is naive, because it assumes that the presence of one feature does not affect other features. And the Bayes part of the name refers to its basis in the Bayes theorem. So it's based on the Bayes theorem. So again, let us have a look at this particular data set. So it is a data set of weather where we are trying to predict. So all these are the features, as we have seen that all these are different features, and this is the output value. Based on these features, we try to figure it out that whether a person should play tennis or not. Now it depends upon, because lawn tennis is an outdoor activity. So it actually depends upon the weather condition. This is a data set related to weather where it says that if the outlook is sunny, temperature is hot, humidity is high, wind is weak, one should not play tennis because the day is sunny and hot. Similarly, when the day is sunny, temperature is hot, wind is strong, again one should not play the tennis. But again we can see some more example where it is saying yes, we should play on the sunny day. When the outlook is sunny, the day is sunny, temperature is cool, humidity is normal, and wind is weak, then one should play tennis. So based on these features, we are actually trying to figure it out that whether, so I'll give this data as an input to the machine learning model, and my machine learning model would learn the patterns available here. Then I'll give a new data as a testing data, and on that particular testing data, the model will predict whether one should play or one should not play. Now, how does naive Bayes classifier takes up this problem is, it is based on the probability. So what it does that based on all the features, it calculates the probability of, suppose with respect to outlook, it checks the probability of day being sunny, overcast or rainy, and it checks the number of yes and number of no with respect to sunny, number of yes and number of no with respect to overcast and rainy. Okay. Similarly, it keeps on checking all the available features. So it has checked for outlook, it has checked for temperature, then it has checked for humidity, again the number of yes and no, for wind the number of yes and no, and lastly it calculates that whether one should play or not. So it checks that the total number of yes are 9 and total number of no are 5. Thus the overall prediction says that yes, one should play the tennis based on the new incoming data. Naive Bayes classifier works on the basis of calculating prediction for all the given features. Okay. Next is the decision tree in machine learning. So decision tree is a quite relatable machine learning algorithm for all of us, because from morning to evening we keep on taking multiple decisions. So multiple decisions, all the decisions have two branches, either yes or no, and again based on that yes and no we take the next decision. Suppose I'm going from home to office, and I first check that whether it is raining or not. If it is raining, yes or no. If it is raining, yes, then I have to take an umbrella, or I have to take a car, or otherwise I'll go with a two-wheeler. So we keep on taking different decisions, and based on these decisions we come to a final conclusion. So a decision tree is a supervised learning algorithm used for both classification and regression tasks. It has a hierarchical tree structure which consists of a root node, branches, internal node, and a leaf node. And leaf node is the final output. It works like a flowchart, help to make decisions step by step, where we have internal node, branches, and the leaf node. Say for example, we have a root node. Within this root node, we'll be making decisions. So decision node would be like either yes or no. Depending upon yes, again we'll take some decision on left hand side, again we'll decide, and again it has some branches and will come up with some leaf nodes. So for example, with respect to this last example of this data set, here we can solve this problem. We can take this data set to decision tree as well, where in decision tree we can have the root node as outlook. Within this outlook, again we'll have three subparts, that either it is sunny, either it is overcast, either it is raining. Again it will have yes or no features associated with this, and thus we'll be able to find it out whether a person should play tennis or one should not play tennis. So this is how the decision tree is working. Say in this example, we need to check the condition like age and gender to split user into different groups. And each group, that is leaf node, gets a prediction score based on the user preferences for the computer games. So we are actually trying to check that whether a person plays computer game or not, depending upon his age, gender, and occupation. So I can convert it into a decision tree where I take a value where I check that if age is less than 15, yes or no. Then if the person is male or female, then accordingly we define a predicted to give a prediction score to the each leaf node. But how do we decide that which particular feature should be considered as the root node? Now, within a data set where there are multiple features available, how do I decide that whether I should go with outlook or temperature or humidity or wind as the root node? Then again, at next level, again have to make the same decision. Suppose outlook is the root node. Then again, with respect to temperature, humidity, and wind, which should be the next root node? We decided based on two key values. These are Gini index and the entropy. So entropy is some disturbance or inconsistency in the data. And the formula goes like that. It actually talks about the probability of yes and no. So it is minus probability of yes log base 2 probability of yes minus probability of no log base 2 and probability of no for all the data points j equals to 1 to c. Okay, this is how we calculate entropy. And the higher the entropy, the less disturbance or the less inconsistency is there in the data. So we consider that particular feature as the root node whose entropy is high. On the other hand, same task can also be performed with the help of Gini index, where the Gini index says that 1 minus summation of j equals to 1 to c pj square, where this pj is the proportion of the samples that belongs to class C for a particular node. So for a particular node, we keep on checking the probability of yes minus probability of no ka whole square. And again, based on this, the value, so we'll actually calculate entropy and Gini index for all the available features. Whichever feature has the highest entropy or Gini index, we'll consider it as the root node. And there are various applications of decision tree in finance, machine learning, medicine, and education, because it is quite simple to apply, but it takes little more time to actually execute. Next, we are moving towards the support vector machine algorithm. Support vector machine is a supervised machine learning algorithm used for classification and regression tasks. It tries to find the best boundary known as hyperplane that separates different classes in the data. It is useful when you want to do binary classification like spam versus not spam or cat versus dog. So when I need to have this kind of bifurcation, I can go with support vector machine. The main goal of SVM is to maximize the margin between the two classes. The larger the margin, the better the model performs on new and unseen data. So we want to actually maximize this margin between the two classes. Say for example, suppose I have these two classes, one is green dots, one is red dots. I can simply put a line and divide it into two classes. But the support vector machine is used for classification and regression, and it works by finding the decision plane that separates data into different classes. But I do not want to simply put a line and then to bifurcate it. What I want to maximize this distance between the two classes. So as here you can see there are three lines, L1, L2 and L3. L2 is in between, so I can actually move L2 up to a point. I can move upside until I am actually touching the nearest data point, that is the nearest blue point. I'll keep on moving this line until this place. Similarly, I can move this line towards down until I'm actually touching this one. So what is happening here is that look at this particular diagram where it says that we are actually having a positive hyperplane when we are moving upside. When from this point I'm moving towards upside, we are actually having the positive hyperplane. When I go down, I'm actually having a negative hyperplane. I can move until a point where there is this nearest data point available with respect to the movement of this line. And this is the support vector from where the name of this algorithm has came, that is support vector. So these two are the support vectors. One is this one, second is this one. One is at positive hyperplane, second is at the negative hyperplane, and this is the maximum margin. So we want this margin to be maximum in order to have a clear classification between the two classes. So we apply support vector machine where we have these support vectors and we maximize this margin which is there in between these data points. And support vector machine can also be applied not only in linear data but also on non-linear data. So we also have linear SVM and non-linear SVM. And then comes the random forest algorithm in machine learning. Now the random forest is a machine learning algorithm that uses many decisions trees to make better predictions. Each tree looks at different random parts of the data and their results are combined by voting or classification or averaging for regression, which makes it ensemble learning technique. This helps in improving the accuracy and reducing errors. So what is happening here that we have seen the decision tree. So when multiple trees are there, it makes a forest. So similarly, in random forest, we'll be having multiple decision trees, and these multiple decision trees will actually make an ensemble learning technique. Ensemble learning technique is, as we have seen, that there are different under supervised learning, there are different algorithms. So I can apply a particular algorithm over a given data and generate output. That output would be say X. But then again, the second thought comes that instead of using one model, if I'll be using multiple models, then the efficiency will increase. And this is what is happening in random forest. Because random forest is an ensemble learning technique where multiple models are being used, and here all these multiple models are actually the decision trees. So we'll be using multiple decision trees to make the decision and to make our output more accurate. So what we are doing here, that the algorithm makes many decision trees, each using a random part of the data so that every tree is a bit different. Then we pick the random features. When building each tree, it doesn't look at all the features or the columns at once. It picks a few at random to decide how to split the data. Now this helps the tree to stay different from each other. Third point here is that each tree makes a prediction. Each tree gives its own answer or prediction based on what it learned from its part of the data. And then we combine the predictions. We combine the answer given by all these trees. So combining the prediction means for classification, we choose a category as a final answer is the one that most trees agree. That is the majority voting. And for regression, we predict a number as the final answer is the average of all the trees predicted. So what is happening here, that I have multiple trees. These multiple trees have taken different features. They are producing an output. This output would be, if it is a classification, this output would be either in zeros or ones. So suppose I have 5 trees and 2 trees says 0, 3 trees says 1. So I'll actually take the majority voting, I'll take majority count, and the majority count says that the number of ones are 3. Thus, the overall output is 1. The overall output is true. Okay. And why it works well with respect to other algorithms? Because using random data and features for each tree helps to avoid overfitting and makes the overall prediction more accurate and trustworthy. So what is happening here is that when all the models are saved, now try to understand it in this manner, that suppose you have all the models which we are using in random forest are basically the decision tree. If I have multiple decision trees, say x1, x2, x3 and x4, and I'm giving the same data to all these x1, x2, x3 and x4, then obviously the output would be same, because I have given the same data to all the models and models are same. So what I need to do, I need to give different data from the same one. So what I'll do, suppose I have 10,000 records, I'll randomly select 2,000 records from this or 8,000 records from this 10,000 records, give it to model 1. Then I'll put this data back to the data set. Again, randomly, I'll select another set of data, give it as an input to X2. I'll put it back, and then again, randomly, I'll select. So what is happening that randomly I'm selecting the data, giving it to the model. The models are same, but now their prediction would be different. And collectively, it will be able to produce more accurate answer with respect to the normal decision tree. So what happens here that we have during the training phase, we have multiple training data instances like class A and class B. And these are the models which we are training by making multiple decision trees. And then we perform bagging, that is the count of majority. So based on the multiple output of class A and class B, we conclude it by combining the outputs and predict the output. Similarly, again, the same
Sir,
thing
here
that
let me tell you that we have only 5 more minutes left with this session, sir.
Okay, ma'am. Okay. So I'll try to cover it up as soon as possible.
Sure, sir.
Again, in this decision tree, we can see that we may have a single decision tree or we may have a multiple decision tree, and it performs quite good with respect to other algorithm. In case of unsupervised learning, because in supervised we have seen that the data is labeled, in unsupervised data is not labeled. So when the data is not labeled, I can perform either clustering or the association. So clustering means making cluster of data. Suppose there is a mall in which many people are coming. I don't know how to, because the data is not labeled, and number of people are entering into the mall. So I can actually categorize this data by performing the k-means clustering, or I can actually have data where there is some relationship in the data by applying a priori algorithm. So in k-means, we apply k-means to check the frequent buyers or the big spenders or the budget shoppers. We can categorize the person who are entering into the shop or who are doing online shopping in this manner because the data is not categorized. So what happens here that we have all these are data points, and we have these red one we'll consider it as the centroid, and we'll try to bring all other data points near to the centroid. So right now it's not a centroid. Again, if I've considered that these red points are the centroid, but it is not at the center, so we'll keep on changing the centroid value until it comes at the center and all other data points are near to it. Thus, this convergence actually makes data into different clusters. And a priori is an algorithm which is used to actually, when person buys product A, he also tends to buy product B. Thus, we use the a priori algorithm. So I'm just leaving this portion and I'm coming to the next part. Again, we have reinforcement learning, and which is based on the punishment and the reward. So agent works in a particular environment, either he gets a reward or the penalty. Like the moment we play any game, action game. So in that game, either we earn a reward or there is a penalty. So we keep on learning through our own experiences. Now, how do we apply AI ML in education that it actually helps us to monitor and to give the customer made or to actually it makes the education personalized. So what is our actual role here that in case of personalized education, ML-driven personalization allows system to tailor education experiences based on the individual student need, behavior, and the learning patterns. And we can use these. You can use these available AI platforms like Dreambox, Newton, Caring Learning, or Alex, or Grammarly, where it actually helps student to perform better. In automatic grading, again we have these available resources like the Gradescope by Turnitin. It automates the grading of exam, homework, and the program assessment assignments. Then Socrative or the Acri, which actually helps us in grading and to give the correct feedback to the student. And in case of predictive analytics, we have these applications like Apaka, then Extramarks, IBM, SPSS Modular. So these are the applications which actually helps us to predict at-risk students who are not performing so well. So what's the reason why they are not performing, which subject they are actually facing the problem? We can identify it with the help of these available AI tools. But again, there is an involvement of ethical risk because there is privacy and surveillance concern, bias, fairness, autonomy and agency, and the mitigation strategies. So because we are actually, this data is very vulnerable because it is regarding a particular student, and we have to give it to a machine learning model to train. Thus, there comes the point that the centralization and the storage of this data make it vulnerable to breach and misuse, exposing students' identity and the private information. Thus, we need to be careful about it. Second, the historical or the selection biases in training data can lead the algorithms that disadvantage marginalized or underrepresented groups, perpetuating to systematic inequalities. Like, I have a data of a particular class where majority of the students belongs to higher class, and there are few students. So there is inconsistency in the data. Data is not balanced. So when the data is not balanced, then definitely the output would be more focused on the bias towards the more available data. And again, there is autonomy and agency because this personalized data is there. We do not know how to actually give authenticity to the student or to the parents for using this data. So lastly, the mitigation strategies would be to employ the privacy preserving technologies such as federated learning or differential privacy to protect the student data, to conduct regular audits for bias and incorporate fairness awareness algorithm to reduce the discrimination, and embed transparency, explainability, and robust consent procedures to empower students and families. And lastly, ethical deployment of ML personalization in classroom demands the balance educational benefits with stringent protections for privacy, fairness, and student well-being. Because a student may feel that he's continuously being monitored because he's using because we are using all these online tools. Thus, we need to apply these mitigation strategies. Okay, thank you so much. I'm sorry I have exceeded the time.
Yes, sir. Thank you so very much, Amit sir, for this wonderful explanation and for your valuable information. Thank you so very much, sir, for your precious time.
Thank you, ma'am. Thanks, everyone.
Thank you so very much. And dear viewers, हम आपको बता दें कि आपको हम जानकारी दे रहे थे आर्टिफिशियल इंटेलिजेंस एंड मशीन लर्निंग की. येस्टरडे वी हैव लर्न अ लॉट अबाउट एआई फंडामेंटल्स. आज हमने बात की मशीन लर्निंग की. कल हम बात करने वाले हैं प्रॉम्प्ट क्राफ्ट के बारे में. हम चाहते हैं कि आप ज़्यादा से ज़्यादा संख्या में इस सीरीज़ का हिस्सा बने, और अगर आपकी कोई भी क्वेरी है, एज आई कैन सी कि आपको बहुत ज़्यादा क्वेरीज आ रही हैं रिलेटेड टू सर्टिफिकेट और रजिस्ट्रेशन, आप अपनी क्वेरीज हम तक पहुंचा सकते हैं हमारे ईमेल एड्रेस पे जो है AICELCIET@gmail.com. आप प्लीज़ अपनी क्वेरीज हम तक ज़रूर पहुंचाएं. एंड लेट मी मेक दिस वेरी वेरी क्लियर, सिर्फ रजिस्ट्रेशन से आपको सर्टिफिकेट नहीं मिलने वाला होगा. रजिस्ट्रेशन आपको NCERT के वेबसाइट पर ही करवाना है. यू नीड टू ओपन एनी ऑफ योर ब्राउज़र और आपको CIET NCERT टाइप करना है. आप हमारे वेब पेज पर जाएंगे, वहाँ पर आपको एक्टिविटीज़ करके एक आइकन दिखेगा. एक्टिविटीज़ पे क्लिक करके आपको वर्कशॉप और ट्रेनिंग सेक्शन में जाना है. वहाँ पर जब आप क्लिक करेंगे तो आपको करंट एक्टिविटीज़ का एक पेज ओपन होगा. वहाँ पर करंट एक्टिविटीज़ में आप इस सीरीज़ पे क्लिक करके पूरी डिटेल्स ले सकते हैं, और वहाँ पर आपको रजिस्ट्रेशन के लिए QR कोड भी स्कैन करने के लिए दिखाई देगा, और वहाँ पर आपके लिए एक फॉर्म भी होगा अवेलेबल. आपको वो फॉर्म भरना है रजिस्ट्रेशन के लिए, और इस बात को आप ज़रूर याद रखें, यू हैव टू रजिस्टर योर सेल्फ, देन ओनली यू कैन पार्टिसिपेट इन एनी क्विज. और वो क्विज जब आप अटेम्प्ट करेंगे दीक्षा प्लेटफॉर्म पर, देन ओनली आपको सर्टिफिकेट प्रोवाइड किया जाएगा. तो आप प्लीज़ इस प्रोसेस को याद रखें, और अपनी जितनी भी क्वेरीज हैं वो आप हमें मेल ज़रूर करें. और हम आपने सभी देखने वालों को बता दें, एज वी आर रनिंग वेरी शॉर्ट ऑफ टाइम, तो इस सेशन को हम यहीं पे रैप अप करना चाहेंगे. लेकिन उससे पहले हम आपके साथ एक बहुत ज़रूरी इन्फॉर्मेशन ये शेयर करना चाहेंगे. इन केस यू वांट्स टू ऑर्डर 4th और 7th ग्रेड NCERT न्यू टेक्स्ट बुक्स, आप ऑर्डर कर सकते हैं अमेजॉन, फ्लिपकार्ट और NCERT की ऑफिशियल वेबसाइट पर जाकर. इसके साथ ही मैं आपको बताना चाहूँगी वो तमाम सत्र जो आप पूरे दिन भर PM eVidya चैनल्स पर देख सकते हैं. हम 2 बजे अपने लाइव इंटरेक्शन का सिलसिला दोबारा शुरू करेंगे, जो कि उर्दू के 3री जमात के तलबा के लिए है. हमारा उन्वान रहेगा फुटबॉल. 2:30 बजे का समय रहेगा इंग्लिश के 3rd स्टैंडर्ड स्टूडेंट्स के लिए. हमारा टॉपिक रहने वाला है बेस्ट फ्रेंड्स. 3 बजे मैथ्स के 4th स्टैंडर्ड स्टूडेंट्स के लिए हम लाएंगे टॉपिक वे इट एंड पोर इट पार्ट फर्स्ट. 3:30 बजे हिंदी के 4th कक्षा के विद्यार्थियों के लिए हमारा सेशन रहेगा मिठाइयों का सम्मेलन. 4 बजे ऑनलाइन ट्रेनिंग प्रोग्राम में हम बात करने वाले हैं पासवर्ड से परे बायोमेट्रिक्स और मल्टी फैक्टर ऑथेंटिकेशन के साथ डिवाइस सुरक्षा को मजबूत करना. और 5 बजे सहयोग सत्र में हम बात करेंगे मिरर विद इन, एक्सप्लोरिंग थॉट्स, इमोशंस एंड द सेल्फ। तो आप ज़रूर इन सभी सत्रों में बने रहें, अपनी क्वेरीज, अपनी बातें, फीडबैक्स हम तक पहुंचाते रहें और यूं ही जुड़े रहें PM eVidya चैनल्स पर और अधिक रोचक और ज्ञानवर्धक कार्यक्रमों के लिए। मुझे रेणु भट्ट को दीजिए अनुमति। नमस्कार।